the groundwater level prior to a storm or a cyclone, natural surface infiltration rate, a number of aspects are there. Now coming to human factors.
Ma'am, you'll have to make it short,
Yeah,
please.
going. So the human factors are there. Here definitely the smart city aspects, if we are taking into consideration, a big change, a solid change can be made. So this slide shows how the drainage, when we are designing the different types of cities or the different types of aspects in cities will affect the inputs for the drainage calculations. If it is a green land, your infiltration capacity, that will be too high. But when it is a concrete jungle, when we are making, we have to provide much higher surface water drainage capacities. I'm skipping because this is already talked. It only means we have to think about how this urbanization is affecting the drainage. Now about the present codes what Indian Road Congress published. One is IRC-SP50, which is for urban drainage. Then, as I mentioned, IRC-SP42 is there, and 34 is there, which is exclusively for the road construction in waterlogged or flood-affected areas. Now, the drainage system, how the controls can be exercised. The controls can be exercised at 3 different levels. One is where the source of drainage starts. Second is on the course of the drainage. As I mentioned, the concept has to be changed from moving the water from one place to the another in a streamlined way to how to make it in the proper way so that we can encourage more green lands, more wetlands, instead of the channelized flow or the pipe flow.
Wrap it up in 1 minute, please.
The pipe flow, we may have to go for the sheet flows, which is encouraging more green lands. I'm skipping. So, how to make new technology to participate to make it green? One concept is to use more materials like geocomposites, which is explained in the MORTH section 700, or again in IRC 34, which I mentioned. It's giving the specification of that. So we can use that. So instead of using 600 mm or 60 centimeter filter, the conventional gravel filter, you can go for very minor, means even millimeter thick geocomposite drain, which will again, this is my last slide, which will again reduce the carbon footprint, which I already mentioned. How it will reduce? Because gravel, definitely when quarrying is an exercise where a lot of carbon emission is there. Again, when the quarries are far from the city, when we are bringing the construction material, that again will increase the carbon emission. So when we are using, even if the geocomposite is polymer, there is some carbon emission. In the G3 committee, we are working on this. It is found that a big amount of carbon credit the country can obtain by incorporating this type of materials. And at the same time, it is a smart solution because it will give cost effectiveness.
Thank you, ma'am.
Yeah, sir, let the final slide. So this is the last slide. So I just want to summarize the smart city. The smart drainage is very important. And for the smart drainage, how we can think about, how we can holistically plan. When we are providing the drainage. It's not like carrying water from one place to the another. That water, we can allow it to infiltrate in the land. We can think about the water harvesting. And again, by incorporating the new materials like geocomposites, which are very thin, which can replace big gravel drains, which the designers are insisting, that will get reduced to very small places with high capacity. So together, we will be achieving better efficiency, better cost reduction, and finally, a smart way of working. That's all. Thanks.
Thank you, ma'am. Cities and elsewhere during monsoons and after monsoons is simply on account of neglecting drainage. We simply go on constructing, building, expanding without giving any thought as to how the natural flow of water is going to be affected. Earlier, Bombay used to withstand a lot of rain. Now in 1 hour's rain drenches it. You see what happened in Gurgaon. So this is a major miss that engineers, planners, and builders, and of course the authorities, they are not giving the due importance it deserves. Greed takes over. Land is very expensive in urban areas. Everybody wants to maximize his profit or whatever it is. But they forget that in the long run, everybody suffers because of that. So more of it later. Thank you, ma'am, for your good talk. Now I'll call upon Shri P. Ravindra Rao for his talk on road development plan for new state of Telangana. We have introduced this in this session as a additionality. So kindly wind it up in 8 to 10 minutes.
Very good afternoon to all of the delegates. Yeah, I think most of you are aware that state of Telangana was formed in June 2014 after the bifurcation from the erstwhile Andhra Pradesh state. Thus, the state of Telangana came into being on 2nd June 2014. So after the formation of state of Telangana, our Honorable Chief Minister called for a meeting in the month of July for a discussion on the state of affairs, status of affairs on the road network. So we had a long discussion, to be exact, on 11th July 2014. Yeah, in the state of Telangana, the development of road network is very much required as in any other state. I think a systematic development of road network is a prerequisite for accelerated economic development in any state. And it is much more important in a state like Telangana, as we have, Telangana state does not have much of rail network, very poor rail network, and the rural areas are not covered by the rail network. So it was thought that we need to go for a massive road development program immediately after the formation of state of Telangana. So then our Honorable Chief Minister directed that, so what would be the criteria for selection of these roads for taking up the capacity augmentation by way of widening from single lane to double lane? I said, sir, generally we go by traffic volumes. The roads which carry more traffic volume, we should be widening those roads. Then our Honorable Chief Minister directed that I think we should have one more criteria, that is connectivity. Connectivity from this, especially he was interested more in giving the connectivity from Mandal headquarters to the district headquarters. So he said we should have a double lane road for from each Mandal to the district headquarters. So that's where we had two criteria in identification of this massive road building program. That is, one is traffic volumes, and the second one was the connectivity. Connectivity from Mandal to district headquarters mainly. And the other criteria is said that we should have from all the district headquarters leading to the state capital, we should have a 4-lane highway. So thus we had for the new state of Telangana, three main developmental activities in the road sector. One is capacity augmentation by way of widening from single lane to double lane, from each mandal headquarters to the district headquarters. And the second one is widening of this single lane to double lane based on the traffic volume. And the third one was four-laning of two-lane roads from district headquarters to the state capital. And the fourth one was formation of ring roads to all the district headquarters. So these four major programs were given by our government in 2014. So then we had a very a situation where most of our single lane roads at one point of time were transferred from Panchayat Raj Department to the Roads and Buildings Department. So most of these roads, we don't have much of geometrically built roads. So we had this predicament of whether to go for just simply widening these roads or go for a complete overall and complete rebuilding of the roads. So we had to take a call on that, and then we collected the data on all these roads, and it was found that traffic levels are mostly in the range of 5 MSA to 10 MSA, and most of the in-situ subgrade soils, CBR was around 10%. Most of the soils were good soils. So then we thought that because 80% of the roads are falling in the range of 10 MSA traffic, and the in-situ CBR soil was around 10%, we thought that why don't we go for a thin layer bituminous concept. I think this is more relevant, and IRC-37-2012 gives that even for traffic volumes starting from 2 MSA to 10 MSA, the layer of thick layer concept is given in the IRC-37-2012. I think, which in my opinion, I think which one the flexible committee should also discuss, that we need not adopt that thick layer of bituminous for this kind of volumes of road. And where the traffic range is in the range of 2 MSA to 10 MSA, I think we can adopt a thin layer bituminous concept. And that's what we did, because there is a huge cost difference if we go for a thick layer bituminous concept. So finally, we decided that we should adopt and we should go for a thin layer bituminous concept rather than following the IRC-37-2012 guidelines, which is a major departure, but which is fully analytically backed by our calculations, which I will go through. Yeah, as I said earlier, most of these roads are single-lane carriageway roads and taken over from Panchayat Raj Department. And one more thing which we discussed for quite a length of time was whether to go for strengthening with a bituminous layer or strengthening with a granular layer. So then we analyzed what is the existing crust of all these roads. Then we found that there is inadequate base and subbase. Generally, it is varying between 100 mm to 175 mm. So the old WBM layers are existing, and over that about 50 to 60 mm bituminous layer was existing. So even the existing bituminous layer is in distressed condition. Most of these roads the bituminous layer is in distressed condition. And we found that if we strengthen these roads with a bituminous layer, it would once again fail within a 2 or 3 years span of time. So we thought that because of these three factors, one is inadequate subbase and base, and the second one is a distressed bituminous layer, an existing carriageway, and the third one is when we wanted to improve the vertical profile of these roads, and improving this vertical profile of these roads by way of putting bituminous layer, it would prove very expensive and costly. Because of these factors, we decided that we should go for granular strengthening of these layers, granular strengthening of these roads. So this is the typical cross-section we have adopted for all our roads. Yeah, what is the basis? What is the basis for adoption of this thin layer bituminous concept? So as you are all aware that there are 5 payment layers in a conventional flexible payment, and as indicated in the IRC-37-2012, they are BC layer, then first subgrade, then JSB, then WMM, then DBM layer is given. Even for 2 MSA, there is a 50 mm DBM layer is indicated in the IRC-37-2012, which is not required in our view. Yeah, after all, what is the design philosophy of any flexible payment design? The design philosophy of any flexible payment design is that the payment composition should be selected such that the stresses caused by traffic loads are not excessive to cause failure of payment layers during the selected design period. This is the design philosophy of any flexible payment. Generally, a flexible payment would fail due to one or more these 3 modes of failure. The first failure criteria is the fatigue cracking of bituminous layer, that is due to high horizontal tensile strains occurring at the bottom of the bituminous layer. This is one of the failure criteria. And the second failure criteria is a permanent deformation or rutting caused by high vertical compressive strains on subgrade. And the third criteria is permanent deformation within the bituminous mix or within the bituminous layer. So these 3 failures, either of these 3 failures generally occur, we observe in any flexible payment. This is the first criteria. Yeah, this is pictorially depicted. This is the first criteria. There the horizontal tensile strains caused in the bottom of the bituminous layer is exceeded, and that's why this cracking up from the bottom of the layer is observed. And the second one is rutting from weak subgrade. Here, because of the excessive compression on the subgrade, the rutting is observed. And the third criteria is that the mixture, the bituminous mixture, because of the high plastic mixture, because that rutting is occurred within the bituminous layer. So these are the generally 3 failures we observe in a flexible payment. Yeah, IRC design method is it's based on analytical approach. There is IIT PAVE software is available. So all the IRC tables, whatever catalogs of payment composition that are given is based on the IIT PAVE software analytical approach. The third mode of failure of permanent deformation in bituminous mixes is generally taken care of by appropriate mix design. The first 2 failure criteria are quantified for design as tensile cracking of bituminous layers as reflected onto the pavement surface not to exceed 20% of the surface area during the design life period. And the second criteria is subgrade rutting, that is permanent deformation as reflected onto the pavement surface not to exceed 20 mm. These are the 2 criteria given in the IRC 37-2012. These are the pavement design life due to these two design criteria, is represented by two design equations. They're also given in the IRC-37-2012. Yeah, and when we took up this massive road building program of strengthening from single lane to double lane, about 6,000 kilometers, costing about 7,000 crores, we have taken up, the government of Telangana taken up this massive road building program at a single go. So we analyzed various payment options. We analyzed especially three payment options, and we have chosen, the designs were done by layered elastic analysis, that is IIT PAVE, and the alternatives are, the first payment option is the conventional payment. I am calling it conventional because it is indicated in the IRC 37. For a 10 MSCA design traffic, generally the payment composition that is indicated in IRC 37-2012 is 200 mm DSB plus 250 mm WMM plus 50 mm DBM plus 40 mm BC, which we did not adopt. And I'll bring out the reasons for that. And the second option we explored was a deep granular pavement with thin bituminous layer. And the third option we explored was a granular pavement with thin bituminous layer with same GSB thickness and WMM thickness, but we taken out the DBM layer of 50 mm and provided only 30 mm BC. So that is the option we finally selected because of the analysis we carried out and came to that conclusion. And the fourth option we also explored was a pavement with soil stabilized subbase and a thin bituminous layer over that. Yeah, these are the calculations. We, using the IIT PAVE, the number of repetitions, the number of the design load